Hello and greetings. Hope you all are doing good. Today I am going to discuss address resolution protocol. We will see what is network interface card, what is a MAC address, and why we need this address resolution protocol and how important it is. So before moving forward, let's first understand what is a NIC network interface card and what is a MAC address. As you can see in this picture, every device, every computer, and every laptop has a network interface card which is similar to the one which is shown in the picture. If you have a PC, then you will have a network card something like this. What is the purpose of network interface card? Network interface card actually connects your computer to a network so it can send and receive data. The network interface card can be wired or wireless. We have a wired card and a wireless card. And we also have a USB NIC, which is also a wireless card based on the USB. Now, every network interface card has a unique, globally unique address that is called the MAC address. And the MAC address is a physical address of that device. This is a globally unique address. As you can see in this picture, this is a network interface card, and this is the MAC address of that network interface card, which will uniquely identify this card. And when it will try to communicate data, send and receive data, that MAC address will be used. How it will be used? Let's see now. So why we use ARP and what is ARP? So ARP is used to resolve IP addresses to MAC addresses. Or we can also say IP is used to map IP with the MAC address. And this is important for the communication to happen. We can also say it's mapping of layer 3 address to the layer 2 address according to the OSI layers. For network communication to happen, computer needs to know both IP address and the MAC address of the destination. ARP is used to find out the MAC when the destination IP is known. So the device who wants to send some information or some data, they must know the IP of the destination. Now let's take an example and see how this ARP actually works. So we have a small network and we have 3 devices which are connected via switch. Let's name them Bob, Ali, and Raj. And we have an L2 switch, and we have this network, and the network ID is 10.0.0.0/24. 24 is the subnet mask, as we have already discussed in previous lectures. Now, every machine, every device like Bob or Ali or Raj, they have a table which is called ARP cache or ARP table. This table is actually a dictionary if you have a programming background. It's a table which contains a key and a value. And the key and the value is the IP and the MAC mapping. So, for example, if Bob wants to send some data, he wants to say, hi, this is the data. Bob wants to send this data to Raj. And Bob knows the IP address of Raj, but Bob doesn't know the MAC address of Raj. Now, how this communication would happen? The Bob will send an ARP request. This ARP request will be a broadcast message. This will be a broadcast message. Now, the broadcast message means this message will be forwarded to all the connected devices. So here we have 2 connected devices. One is Ali device and one is the Raj device. So the Bob will say, I want to talk to 10.0.0.7. Please give me your MAC, and here is my MAC. So the Bob will also give its MAC address with this ARP request. Bob will append its MAC address with this ARP request, and this ARP request will be sent to the switch. The switch will broadcast to all the connected devices, to the Raj and the Ali. Ali will look at this ARP request and it will discard it because the IP address is different. This is not Ali's IP address. The Raj will receive this and it will say, oh yeah, it's mine, and yeah, it's me, and here is my MAC. and the Raj will send its MAC address to the Bob, and the Bob will then add this entry in its cache here. And now the actual message, which is the hi message, it will be sent to the Raj. Now the actual message is routed for the Raj, which is the hi message. And in the same way, if Bob wants to communicate with Ali, the Bob will first check in his cache table that do I have the entry for the 10.0.0.6 address, and do I have a MAC? And it will find out, no, I don't have a MAC. The Bob will send the ARP broadcast, the ARP request, which is the broadcast message. The broadcast message will be then received. This time, this broadcast message will be received by Ali, and it will say, oh yes, it's mine. And then it will send his MAC address to the Bob. And then the Bob will record that in its ARP cache. And then the communication will happen. And this ARP cache is available in all the devices, in Ali's devices and in the Bob device as well. Now let's look at a different example where we have a different network. So here we have 5 devices in one network, and 2 are external network, or we can say foreign network. And the IP of this network is 192.168.1.0/24. And we have a switch and a router. Why we have a router? If we want to communicate to the external network, we need the router. And we have the IP addresses and the MAC addresses of all 3 devices. And we also have a MAC address and IP address for router. We have a MAC address for the switch also, but I am not showing it here because it's not required. Now, we want to communicate, the Bob wants to communicate, it wants to send a message, hi, to this network, to the 192.168.10.0 network, which is a foreign network, an external network. And to send this message, Bob has to send the ARP request to the router. The router is a default gateway. I will make a video on the default gateway, and we will see how the default gateway works. But for now, you must understand that router is the one which is connecting this network, which is 1.0 network, with the external network. Now here, this is our internet, and this one is another network. So this time, the ARP request, there will be an ARP request, and it will be, as we know, it's a broadcast request. The Bob will check in its ARP cache table, and there is no entry, there is no MAC address for the router. The Bob will say, hey, 192.168.1.1, please give me your MAC, and here is my MAC. Bob will give its MAC address, and now it's targeting the router, the router IP. The router will receive this message, the broadcast. This broadcast will be received by all the connected devices, because broadcast is the special message which is sent to all the devices. Ali will receive and it will discard. Anju will receive and it will discard. The router will receive this message and it will say, hey, yeah, it's me, and here is my MAC. The router will send the MAC address to the Bob, and now Bob will forward the message to the router. Now this data will be sent via the switch to the router, and then the router will route this request to its destination. And also the MAC address will be recorded in the ARP cache. And this is how the communication will happen. So we saw 2 cases. The case 1 was the internal network, where a machine or a device wants to communicate within its own network. And in second case, we saw if a device wants to communicate with the external network, how that can happen, and how the connection can be established, and how the message can be forwarded to the destination. Now I will show you the ARP record in my local machine, so you can understand what it is. Now here is the Windows PowerShell, and here I can write a command which is ARP and -A, And as I write this command, you can see that I have some entries in the ARP cache. This is the ARP cache, which is my local ARP cache, my machine's ARP cache. So let's talk about, let's try to see something. So we have this interface 192.168.19.1, and this is the broadcast address, as you can see, and this is these are the internet addresses. Then we have physical addresses, the MAC address. This is the MAC address, and then we have the type. In the internet addresses, there are different physical addresses, and the one which is all F, as you can see, this one. So this is the broadcast address, and this is the IP of this is the broadcast IP. And to broadcast something, the physical address is all F. So we are not sending it to a specific device, but what we are saying is broadcast this message to all the devices. And some of the entries are dynamic and some of the entries are static. What does it mean? The dynamic entries are automatically recorded while doing the communication, and the static one are the one which the administrator or the manufacturer has set in. So I hope this will be helpful, and I'll see you next time. Thank you.